Hello guys, Matt is back with another video, and today we are on problem 4 in the Project Euler series. I've realized that there's different approaches to most of the problems that we're solving in the series, and I'm not going to be able to go through all of them. I did that in the past video, but from now moving forward, I'll just try and do the one that I think is more optimal. I'll just tell you the different ways in which you can approach the problem, but I will continue to choose the one that is best. You can look at the other approach and comment down below if you need any help, or if you just want me to see the solution. Maybe we can discuss what else you can tweak in the comment section below. But yeah, for the new people, if you haven't already subscribed, please click on the subscription button below and make sure you hit the notification bell so you get notified whenever I release a new video. Let's go. So I've already taken the time to copy our problem statement from the Project Euler website, which reads as follows. A palindromic number reads the same both ways. The largest palindrome made from the product of two two-digit numbers is 9009, which is the product of 91 times 99. Find the largest palindrome made from the product of two three-digit numbers. So we've been told what a palindromic number is. Palindromic number reads the same both ways. So looking at this number over here, this is 9009 when you're reading it forward, and it is still 9009 when you're reading it backwards. So that's what a palindromic number is. So 333 would be a palindromic number, 111 would be a palindromic number, 90009 would be a palindromic number. You can change that to 1, it'll be a palindromic number. So it'll be 90109, 90109, both ways. So that's what we'll be looking at today. So our problem is to actually find the largest palindrome made from the product of two numbers. So there are two ways we can do this. The first way is to get the product of two three-digit numbers and see if they are palindromes. And then from those palindromes, see which one is the largest one. So, or we can make palindromes and then find out if the product is actually two three-digit numbers. So you can choose whichever. In this case, I'll be looking at the second approach, where I'll be making palindrome numbers and seeing if the product of the palindrome number is two three-digit numbers. So we'll be finding the factors of that. That's the approach I'll be taking. So for that means I will need to have a function that makes a palindrome. Now let's look at a couple of things. Let me just open the node terminal over here. So I'll just type node in my terminal. So let's just look at a few things before we can start. If we're to look at the highest product in our solution, we would need to look at the highest numbers we can multiply would be 999 times 999, right? Which gives us that, which is a 6-digit number. Now we know that for our solution now we need to make a palindrome. So how do we make a palindrome? We're going to look at our product. So we'll have our 3-digit number as an input, and then we'll reverse that 3-digit number to try and get a palindrome. So I'll write that so you can see it. Sorry, I'm supposed to write here. So I'll write a function called make palindrome, which takes in a number and then returns a palindrome. So what are we going to do? So we're going to take the number that we get from the input, reverse it, and then add the two together to make our palindrome. So I'll go const reverse. I'll call this reverse. So reverse will be, so we were receiving a number here. To be able to reverse it properly, I'm going to convert this number to a string by using the toString function on our number, and then I'm going to split it with nothing. Let me just show you how this what this looks like right now. So let me just open the node terminal here so we can run it quickly. So when I'm going to say const n equals to 100, right? Which is our number. So if I say n dot to string dot split by an empty string, so this is what this thing gives us. So I'm doing this because we don't have a reverse function on our string. We have a reverse function on our array. So I can actually, from here, we know at this moment this is an array, and then since this is an array, I can actually reverse the array. So after reversing the array, I want it to be I want to turn it back into a string. So to turn it back into a string, I'm going to join it with nothing, so that there's spaces in between. So let's just see. Let me just show you again what the result would be here. So if I join with an empty string, you see, if I do that, so I'll just add the reverse onto this. Go reverse. Sorry, reverse. This is a function. So yeah, so this line is the same as the one we have in there. So we took 100 and then we reversed it and got 001. So this is now 001. So now we want to make a return. So I'm going to use string interpolation, and then we return n and then the reverse of n. That should give us a palindrome. So when we give it a number, any number, it'll give us the palindrome. It'll make a palindrome from that number. So let's just test our function out. I'll just console. Let me just close here. Console.log. I'll call it make palindrome. So if we make palindrome, give it 100, this should give us the same. Yeah. Nope. Just node. So you see, we gave it 100, and then it gave us that, so which is a palindrome. So, but we want that palindrome to be a number. So converting this to a number, I'll just put a plus there. So putting a plus in front of a string converts it to a number, like that. So now if I run it again, we'll see that it changed from being a string to being a number, a palindromic number. So we're done with that. What are we going to do? So now we need to find the palindrome product. So I'll create another function here, palindrome. So we'll be making our palindrome from our 3-digit numbers, right? So this is what I'm going to do. So I'm going to start off with the highest number we can look at. So this will be our factor. So it will be 999 to start off with. I want to loop through the palindromes that I'm making and find out if the product 3-digit numbers, right? I'll just run a while loop here. We'll see what condition to put in a moment. So I want to make my palindrome, right? Make my palindrome from my factor. And then I want to loop through other 3-digit numbers. So I'll say let our favorite iterator I equals to 999, and then we're just trying to go lower until we've exhausted our 3-digit numbers, and then I'll just there. All right. So if our palindrome, right? So we have our palindrome over here. So now if our palindrome divided by our I is greater than 999, then we don't need to look at it because we know that it is not a product of 3-digit numbers. So we're just going to ignore that. So we'll actually, in this case, just break, and so that we can move on to the next palindrome. So once we break out of, because we'll break out of this for loop over here and look at the next palindrome. We don't have to look at this one because it is not a product of 3-digit numbers. Because this palindrome, our number over here can actually be anything, right? So like the number, like if because here I'm giving it, to start off with, I'm giving it 999. So our first palindromic number will actually be 999999. What's the product? What makes up 999? This number over here. So it is actually not a product of two 3-digit numbers, like, because we looked at the highest 3-digit number value we could find, which is less than this one. So we know that this is actually not a product of two 3-digit numbers, so we don't want to look at that number. So that's what this statement is for. So now, but if our palindrome is divisible by I, right? If our palindrome is divisible by I, then we have found our palindrome, because we know. So that means we can return that palindrome over here. That means we have found our largest palindrome. So we know this because we are starting off at the highest number in our case, 999. And then if 999 fails, we'll move on to 998. And then because we are moving down, the values of our I, that means we're actually finding, as soon as we find one, that will be our largest palindrome. So yeah. So, but one thing also that we need to do, we need to decrease our factor every time. So that means here, once we're done, we just need to decrease our factor as well. Assuming that we find, so we're assuming that we'll actually find our palindrome. So our while loop, I can just make this true over here and see if this actually works. So yeah, we're starting off with our factor of 999. We make our palindrome. If the product of if one of the factors of our palindrome is greater than 999, then we break. We don't want to look at it any further, because we know that that's not what we're looking for. And then after that, otherwise, if our palindrome is divisible by I, which is what I was missing over there, so then we return our palindrome. So yeah, let's see if this is the solution. So our console.log, know the drill, and then I'll go do that and then see if we have found our largest palindrome. So let's see. So is this even a palindrome? 906,609. 906,609. That is a palindrome. So let's test it out. Let's see. 92907. And that is the correct one. The question 5, problem 5, in the next video. Let's go.